All right. So what I'm going to do is I'm going to kind of give you a little background about myself. I've always wanted to know a little bit about my instructors, I should say. And so let me give you a little background. I come kind of a different background as I stated. So I'm grew up here in Arizona. I don't know if you're familiar with the little small town east of here going up to Globe, Miami, but if you go into Globe, Miami, you blink your eyes, you're going to miss my little hometown. It's called Superior, little small mining town. Now, I left there 100 years ago and joined the military, so I am a veteran, Air Force veteran. I was a civil engineer, also a Vietnam veteran, so I got an opportunity to travel to different places or some places that I was stationed at. Upon discharge, I have a question. Well, thank you. And like I said, that was 100 years ago. So upon discharge, I got discharged down in Tucson, and I ended up from there moving to Kansas City. And so I started my education. I started off as a business major of all things. Okay, so I'm not even near science at all. I've always had a yearning to learn it, but when I attempted to learn the science, it was the way it presented quite different. Didn't quite understand it. So it's not till I got to Kansas City that I learned. I was taught a whole different way of chemistry, and I really enjoyed it, and I kicked in. Well, I got 10 kids. I got 7 boys, 3 girls, and 6 grandkids. So I'm an organic chemist. Okay. My educational background. Well, like I stated, I ended up in Kansas City, and I used my veterans benefits, a VA, to do my undergraduate. I started at Avila. I finished up at Avila University in Kansas City, Missouri. At the time, it was called Avila College, but now they offer master's degrees, so now it's university. Got my bachelor's of arts in chemistry. Um, I initially started there as a medical technology major. And so I took a lot of classes with respect to hematology, anatomy, physiology, and I was right at that point. You spend 3 years in taking your classes, then your last year is spent in the hospital learning how to do the test. Well, right prior to starting my last year, we went and I visited the hospital. I saw what they were doing, which is basically just putting test tubes in machines. And I thought to myself, no, I want to learn more about how that test is done. So at that point, I switched over to chemistry. So I was like 3/4 of the way done with my degree, and I switched over to chemistry and had to take more chemistry. So I got a little bit of wide background of different courses. So switched to chemistry. I finished up my bachelor's there at Avila University. Started my doctorate work at the University of Kansas, and there in Lawrence, Kansas. I did that for a year, but I was commuting back and forth for a whole year, about an hour and a half drive. Too expensive. So I transferred over to University of Missouri in Kansas City and cut my commute time by a lot of time and plus cost. So I finished up and got my doctorate in organic chemistry. Now, so since then, from there, I went into academia for a little bit, but then went into industry. And I was a research scientist for a long time. So I'm a retired research scientist. My area of work was even though I was a chemist, once you get in industry, you really have to learn a lot of fields. So I got into process and product improvement, which basically meant you look at a product, you look at a process, what can I do to make it better? Obviously for the company, make it more efficient, so on and so forth. I am an adjunct at both at GCC and SEC. And at one time I'm not doing that anymore, but I was also adjunct at Carrollton College, where there I taught chemistry, math, and physics. But I've been doing adjunct at GCC now since when is it, 2015. It's been a couple minutes that I've been doing this, and I've been doing at SEC for about a couple years. So I really enjoy when I keep my fingers in the ball game, so to speak. Okay. Um, so as I stated, retired, but my experience is quite very wide. Yeah, I worked in construction for many years. I did construction and civil engineering in the military. Got out, did construction. I've also done customer service work. I've worked in food and retail industry. While I was process research scientist, I was also into programming, computer programming. It's an archaic language now. It's called Delphi, but it's very similar to a language called C++. And I also did caregiving. So a little bit of everything, kind of keep my hands in a bunch of things. So anyway, what I want to do is I want to first move on. I'm going to come back to this. This is our schedule. We'll come back to this in a second. Let me go to the syllabus. I hope you all had time to read the syllabus. And there's a lot of reading there, but I'm going to just hit on the key points about it. There's a lot of stuff in there that SEC requires that we put in. It's for your information, so by all means, please read it. But the first page is basically the class. Okay, class starts today. It officially ends on the 22nd of July. Okay, now, which is a point. Remember this. We have assignments to do, online assignments. Now, I keep those assignments open until the 22nd. Okay. However, assignments have due dates. Now, that means that if you miss the due date, you didn't miss it completely. You can still go do it, but there is a penalty if you pass the due date. And we'll talk about that in a bit. So if you're missing assignments, keep in mind, you can go all the way up to the 22nd of July to complete them, except the exams. The exams are specific one day only, but I'm talking about the homework that is associated with the chapters and the labs, okay, in the lab. So those assignments will be open until the 22nd. But please do not wait until, the last minute to go back and complete them, because some of the lab assignments require 2 to 4 hours of sitting down and listening to videos and doing some reading and answering questions, okay? All right, so my information, if you need to get a hold of me, the official means to communicate with me via email is through Canvas, using Canvas email. That's our official one. That's the official record. So now, occasionally Canvas goes crazy, and it has a couple of times. And if that ever happens and you need to communicate with me, I give you my scottsdale.edu email. You can utilize that email. It will get information to me. All right. I don't have an office location, obviously, but we do have the Zoom, where we can converse if you need to if there's a problem and I don't have office hours this summer, but if there's a challenge and you need to have some time with some questions, shoot me an email and we can discuss when we can set that time up, okay? All right, course description and so forth. Right, based on the Maricopa requirements, all the community colleges requirements, everyone taking Chem 130 has to fulfill these objectives. And there's 26 objectives which pertain to topics of chemistry that we have to cover. Okay, this is like an entry level chemistry. We're not going to get into deep detail. We're not going to get into heavy mathematics. Okay, and a lot of times I get the question, I can't do the math. Well, I'm here to tell you, if you can multiply, divide, add, subtract, you can do the math. There's a little bit of algebra, very, very little, but very subtle. We're not deep into calculus or anything of the sort, okay, or geometry, and so forth. So it's add, subtract, multiply, divide. And algebra with respect to understanding that units can cancel. Units are like the algebra. Algebra, we talk about letters, A times A times B, things of that nature, A squared divided by B squared. And review that general algebra, because those letters can be units, can be units that we can use to cancel each other out or to multiply each other. Okay, but we'll get to that. So it's not sophisticated mathematics. A lot of information there about the textbook. The textbook, you don't have to purchase a textbook. It is all in PDF format, all 12 chapters. This is a textbook that was created by Maricopa instructors, and we utilize it. I utilize it not only at GCC and at SEC. And so everything you need, you will be put in modules on the course website, and I will talk about that here in a bit. All right, what do we have with respect to assignments? Well, let me break it down. Okay, we do have homework. Okay, every chapter has homework except chapters 10 and 11. Those two chapters are combined. All right, so you have 15 homework assignments, short, roughly 10 points apiece. The homework itself is worth 15% of the overall grade. Of those 15 homework assignments, the 3 lowest scores will be dropped. It's automatically dropped by temps. Okay. Now, every homework allows for 2 attempts. Okay. Now, what does that mean for you? Well, here's an opportunity, for example. This is just an example. If it works for you, if it doesn't, you try something else. What a lot of students in the past have done is they take that, they go read the chapter, they get ready, and before I even present the information, but they read it on their own, and then they do the homework, okay, and then they see how they do, and then they wait until after the chapter's done and we completed and we did the lecture part here, and then go back and do the second attempt. And that really helps because it really puts a perspective in the topic and what to expect. Because you're familiar with the topic. And when I start talking about it, you're like, okay, this makes sense now because I understand it better now. Okay, kind of gives you an introduction to it on your own. So that works for you, try that. You do have a second attempt. Remember that even though this particular assignment will remain open until the 22nd, there is a due date, okay? And the thing about homework, the due date, the dates are going to be flexible because they're dependent. I will not make a homework due until we get done with that chapter. Okay, so if there's a chapter that's coming up and said is due and we haven't completed it, don't worry about it. I just haven't had time to move the due date over. But I would not have you complete a homework until we were done with that chapter. So that means that after that due date, there will be a penalty. It's 5% per day until the 50% mark is met. What does that mean? All right, so it's due today, for example. Well, 5 days from now, okay, 5 days from now, you are at the 50% mark. That means that after 5 days, the maximum points you can get for that assignment is 50% of what it has, what it's worth. So if an assignment is worth 10 points and you wait 5 days, well, and if you answer all the questions on day 6, well, the maximum points you can get is 5 points, okay? And so don't wait for that because, you want to get to all the points that you can get, obviously, okay? The incentive in that is that we want you to, be aware you got an assignment coming up, knock it out. All right. So homeworks are worth 15%. Now we have Roman numeral number 2. This is called a nomenclature exam. It's a separate exam here. It has a multiple of attempts. You have until the 22nd to take as many attempts as possible. As per SEC's requirements, I've been told this is their requirement. It states that there's 20 questions and you must get an 80% to get the full credit, the 80% plus. If you make 100, yeah, of course you get the 100%. But if you hit right at the 80%, you're good. You passed it. You can continue to improve your grade or leave it at 80%. Anything less than 80%, it gets set to 0. So you start again. Okay. Now, what that means is this. What is this nomenclature? We're going to be talking about chemicals, obviously, and we're going to start learning how to name these chemicals. And all these chemicals have a name. So we're going to go either given the formula, determine the name of that chemical, and vice versa. Given the name, determine the formula. So that is called nomenclature, naming the formula and or give the correct structure. Now we have an additional resource to aid you with this, and I would start learning, get that resource to start learning that now. If you what is it? If you finish, you get your 80% or better by the end of week 4, you get a 1% bonus on that. Okay, FYI. So that's 1% bonus would be. Oh, look, 1 second here. March 19. So you get another additional points on that. 1% of 20, 2 points. All right, and that is worth 10%. Now, you might think it's not a lot, but if you're on the border of a grade, that 1% can either make you or break you as far as the border. So if you're sitting there in like a low C and you don't complete that nomenclature exam, it can drop you down to a D. Now, right now, there is no grade in the nomenclature exam, but I will, in about 2 weeks, I will put a 0 in there, okay? The reason I do that, okay, and I repeat, the reason I do that to give you a clearer picture of your true grade, because the grade that you see from your end is based on assignments that have not been graded yet or not been done. So that's not your true picture, that's your progress grade. And so if you put off doing the nomenclature grade, you might be doing, let's say, a B or even an A, thinking that's what you're doing, but that's not your true picture because you haven't attempted the nomenclature grade. So I'm going to put in a 0 in about 2 weeks, maybe 3 weeks, and then you're going to see what effect that 10% does. Okay. All right. So keep that in mind when you see that. So don't be surprised. We will have 5 lecture exams, again, online. Okay. And right now, when we get into the schedule, you'll see right now in the beginning, we start a little slow, but it's going to kick in. So basically every week, you're going to be having either an exam, lab due, or homework due. Okay. And then the final exam, which is comprehensive, generally made up of about 60 questions, is worth 15% of the overall grade. Okay. Now, what happens if you happen to miss an exam? Understand, you got work, you got family, variety of things. If you miss an exam, or if you can't make an exam at a particular date, please send me an email. I don't have a problem with adjusting that day 1 day before or 1 or 2 days after. Okay, I cannot go more than that. But if you shoot me an email, I can change that for you for 1 day after 1 or 2 days. Now, if you miss an exam for whatever reason and you can't make it up, or we can't adjust it for you to do it, then it's still not a lost cause. Don't get too upset about it. But I will take your final percentage grade of the final and substitute that grade for that missed exam of the exams 1 through 5. I can do that for only 1. Okay, so keep that in mind. Keep that in mind. All the other missed exams, uh, I I can only give you a 0 if you missed it. We can't help you out with the time there to do it. All right, there are 11 lab experiments. And then notice that's a lot of work. But remember, this is the normal 16 weeks of chemistry, except, in the summer, I took out activities because normally in the regular semester, we had activities, different things to do. I took them out because of the time constraints. So the only thing you are lacking are activities. There'll be 11 lab experiments and 2 lab exams. We'll have one about halfway through, and then one for about a week before the finals. Okay. Also, labs experiments will be submitted after due date. Also, will be given the penalty of 5% per day until the 50% mark. Keep that in mind because these labs are worth 100 points. Okay, so if you go after day 6, the maximum points you can get out of that exam is 50 points. Okay, so experiments are worth 25%. All right. Oh, one more. Somebody has a question. Yes, good question. Skylar, labs are only 1 attempt. Okay, but they literally open. I've had students go in there, start the exam, start the lab, and then come back to it, days later, and it shows the time of completion because we look at the log. Sometimes I've had a whole week it's taken, but yes, that allows, the labs are allowed, you can go back in, but you only have 1 attempt, and there's no time limit on that. Okay. So the overall our scale is slightly different for SEC. You get 100 to 88% for an A, and then so on down the line there. Okay. Overall lecture, we have 50. It's worth, homework 15%. The lowest 3 will be dropped. Exams, there's 5 exams worth 35% of your overall grade. The comprehensive is worth 15%. That nomenclature exam is worth 10%, and the experiments are worth 25%. Okay. Now, with respect to respond time, you send an email, it's hooked up to my phone. That's why it's important that to use the Canvas email, because I will be notified through my cell phone when I get a message, and I'll respond to you as soon as possible, but 9 times out of 10 within 24 hours. Okay. But do use the Canvas email. And then again, as I stated, I know last semester we had a little trouble with somebody trying to hack into the system. So we were down for a little bit. And so the email wasn't working, but try this one here. This one, the EDU email should work when Canvas itself is not functioning. All right. So if there's anything that needs hand grading, there are some questions that you input, you type in an answer. I need to go in there and hand grade those, So yes, you have it shows you what you completed, but then I need to go in and grade what you wrote about a particular question. And so that I get that knocked out as soon as I can. And normally 1 to 2 days, I got it knocked out. Yeah. Okay. Now, attendance. Other than this first meeting, which is required, and you saw my email flying because it has to do with refunds as far as the cashier's office, something going on with the business part of it. But obviously the lectures, treat it as you were on campus. I'm not going to say you have to be here, but we are doing 8 weeks of chemistry, and a lot of times I bring forward information that is not written in either the textbook or anything else, and so sometimes I'm able to help you understand that information a little bit in a different manner. Okay. And so missing a lecture, it's up to you. This is your money. I'm here to help you to accomplish your goals of getting past this class and eventually getting that piece of paper that you need. That piece of paper is important. I don't need to tell you something you don't already know, but I can tell you this from personal experience. Oh, the nomenclature exam, that is an exam that I'm going to answer this quick question here. Deals with naming of chemical compounds, either given the formula, give the name, give it a name, give the formula. And I'll give an example of that in a second. Okay. All right. So from a personal perspective, with respect to this piece of paper that you're striving for, this is just, getting your associate's degree, and hopefully that's going to help you out to move on to get your bachelor's. Some of you are probably going to go on, maybe get your master's and even your doctorate. Some of you, will go on. But that piece of paper, whether it's an associate, whether it's a certificate, associate, or a doctorate, open those windows you never will believe were available. I never in my life, growing up in Superior, as a little boy, ever thought that I would end up being a research scientist and making products that were utilized throughout the world. And I couldn't have done it without that piece of paper. And that piece of paper, to get that piece of paper, it does take some work. So you're gonna have to somehow find your balance. You're balancing your needs with family and work, with education. You got to find some happy medium. What works for one person does not necessarily work for another. So, got to find that spot. All right. So attendance, obviously, I will be here every Tuesday, Thursday. Okay. Not the end of the world if you miss one or two. I will record everything. And I have a link, and we'll get to that here in a second, where I upload all the recordings up to my YouTube channel. And so if you miss one, you still have the opportunity to listen to what we talked about for that day. Okay. Now, if you have so attendance as per online definition of Maricopa's community colleges is this. Is if first of all, if you are more than 2 weeks and not logged in and not done anything, then I have to drop you. Okay. So let's not let that happen. Also, on top of that, if you have not submitted at least, you got 5 missing assignments, because if you got 5 missing assignments, that generally means you haven't really logged in and done anything. So keep that in mind. I have the option to drop you from class. Okay. So if you're not logged in greater than 2 weeks and you're not submitting any assignments during this time, then I'm required actually to withdraw you from class. So keep that in mind. And I check that periodically. And if I see anything's missing, I will send an email just to give you a heads up. Hey, okay, you've got 2 or 3 missing assignments. You may want to go back there and knock them out. Okay. So now we're going to be here doing the lecture time, 2.5 hours of sitting here listening to this crazy scientist talk about chemistry. Okay. But on your own time, it could vary 4 to 6 hours, depends, of course, you got the lab, you got study time. So you're going to spend some time to get through this class. So arrange yourself time-wise, time management. I had a family going through undergraduate school and graduate school. I fully understand if you have a family. There are many a nights I was up 2 or 3 in the morning studying, studying any time I had a few minutes of time, any way I could figure out, didn't sleep much during that time period. Didn't put it to you that way. Okay. If a point comes, which I got to talk about, I hope we don't reach that point, but you need to withdraw for one reason. There's a time limit that you can initiate it from your end, but once we pass that time, I can initiate it from my end. Now, if you take the final exam, I can't withdraw you. You're committed to the end of the chapter, obviously, to the end of the class. So if we come to that point and you're thinking, well, maybe I should withdraw better, let me know and I can have it done. Okay, it's not a problem. I can do that, but I can't do it after you take the exam. Because sometimes I get, well, what, let me see where I hit. If I take the final exam, can I withdraw after that? I can't do that. So keep that in mind. All right. Any questions so far? Because I'm going to move on to our schedule because there's a lot of stuff here about GCC requires us to put in our syllabus. I leave that up to you to read that at your leisure. Of course, talking about being honest. Yeah. All right. Got a question. I need to move down to the. Yes. Let me. So I'm moving down to the lockdown browser. Let me move it down there now. The exams and only the exams require what is called the lockdown browser. Okay. Now, what that is it's a browser in itself. It's an app that works on both Mac and PC. And what it does is it locks you. The browser locks you. You can't get out of it until you finish the exam. Okay, that is to prevent one from going into different areas. Well, all I can say is this: if somebody's going to want to cheat, they're going to do it. The lockdown browser is not going to help you. I hope you don't do that because the only thing you're cheating yourself, with respect to doing the best you can. Won't say much about that, but here I gave the information on where to get it. If you already use the lockdown browser in any of the Maricopa campuses, then you're good to go because the lockdown browser is made specifically for the school. So you can't use a lockdown browser from any other school because it won't work. Okay. And so I gave the link in there that you need to, where's it at? There it is. There's a guide. Yeah, let me back it up a little bit. I gave you the link that you can go either to your Apple Store or your Windows Store to download the link. Okay. I also made it so you can use the iPad if you're using an iPad, so that's usable. So download it. There's a student guide here. Okay, here's the requirements, Windows for a computer. Now, it won't function on a cell phone. And so doing the exams, there's no problem with you doing all the other assignments on your cell phone. A lot of students have done that. But for this, you do need a computer. Okay. So if that is a problem, please let me know. School does offer rentals, not rentals, but does lend out some laptops to be utilized. So let me know that is a problem. Okay, you need an access to a computer to do your exams, only for the exams. Okay. And like I said, it's an app, so it's a program, its own browser. It prevents you from using any other applications while it's running. As you load it up, they'll ask you this, they'll tell you shut this down, shut that down. They'll ask you to shut all the programs it's been programmed for to look out for. Once that is done, you go into the it takes you to the login of Canvas. You log in, select the course. Okay. From the course, go to the assignment, hit the click it, and you start your exam. Straightforward, nothing more. Okay. Any other questions about that? Now, I do have an extra credit assignment there that you really need to get it knocked out before this week, because if you don't have the lockdown, it tells you where to go get it, information about it, install it, see if it works. If it works, answer the questions. And then once those questions have been answered, I get flagged that they've been completed, then I will I will give you extra credit. Okay, there's something going on here with my, I'm missing something here. Where'd it go? All right, let me share something else real quick. Yeah. This is the schedule. Okay, today's June 1st. It's highlighted in yellow. Okay. And so today we're going to be talking about, we're talking about what we're talking about, but I'm going to jump into, hopefully get into chapter 1, knock that out. No, well, at least get half of it done. But you can see tomorrow we got lab 1 coming, and then Friday you got lab 2. Okay. This is a typical schedule for the summer. If we were doing this face to face, this is generally what would be happening. You'd be doing 2 labs on face to face. You'd be here, we'll be face to face 4 days a week for the summer session. So this is not unusual. I have 2 labs due each week, starting the first week. Now, your first homework's not due till next Monday. We should be done with chapter 1. And then you got again that Wednesday chapter. Those due dates are tentative. It depends how we progress with respect to the chapters. A lot of times, some of these chapters are pretty long. We have to go a couple of days with them. Sometimes they're short. I got one chapter, it's roughly 12 slides, PowerPoint slides, and we knocked that out in 30, 40 minutes. Okay. The first exam is scheduled for the week of the June 13th, which would be what, June 15th, I believe. We'll look at that schedule there. Yeah, June 15th. That's exam number 1, which is chapters 1 through 3. Okay. That same week, you have your first lab exam, which are covered labs 1 through 5. Okay. And then right after that following week, you'll see we'll have exam number 2, then number 3, number 4, and so forth. Okay. So after the 3rd week of the semester, we're going to have literally an exam, online exam every week. I pushed it out far enough so we will have completed those chapters prior to that exam time. Now, during that exam time, obviously, if we were on campus, we will have it there in class and we wouldn't have a lecture. But the way I work it is we continue for that day with the lectures. Now, 1 or 2 things. When on exam days, we will, if you have any questions, because I leave the exam open it's open from 7 a.m., I believe, to 10 p.m. I'll verify, 10 or 11 p.m. Open. That exam is open in that time period. So that gives you that full day to pick a time for you to go in there and knock out that exam. And so if there's no questions, if you have questions, feel free to come during the Zoom session with any questions concerning the chapter. If there are no questions, then I continue on with the next chapter. Now, the advantage of that is this, that toward the end of the semester, that we end up with what we call study days toward the end, 1 or 2 study days where we have no lecture. It's just I'm here, you ask questions, boom, we knock it out. If you don't have any questions, keep up with the good work, and I'll see you, when I see you. Okay, so keep that in mind on exam days. Yes, we will continue with the lectures and/or answer any questions you may have. Okay. Now, when it comes to that questions, given we have a Zoom, please come with specific questions. Okay. It's difficult to answer a question that says, I don't understand some concept. Okay. But give me a specific example of what you don't understand. We can work with that. We go from there and expand on that. But if you give me carte blanche, I don't understand that. It's an open open book there. I don't know where to help you out. Okay. So as you study, keep notes, write things down. I want to explain this part a little bit better specifically. And then when you come to class, that will help. That'll help me to help you. Okay. So that's our schedule. You can see it's pretty tight. Keep you busy. And so the last yellow one, that is the lecture final exam comprehensive. That is also the day, that's June 22nd, July 22nd, excuse me. That is also the day that everything Canvas basically shuts down. So be sure to knock out as much as you can. Okay. Before that date, otherwise you can't have access to it. The exams, you only have one attempt, and they are timed. Most of the exams 1 through 5, I believe they're about 75 minutes apart time-wise. The final exam is about 110 minutes, almost 2 hours. And so go in there to verify the time for yourself, and then plan accordingly. Give yourself sufficient time to finish that exam, because if it shuts down at 10 o'clock or 11 o'clock p.m., it will shut down at 11 p.m. Okay. If you go in there at 10:30 to start, come 11 o'clock, it's going to shut you off. Right. So if you come to me and say, well, I was on there and it turned off. Well, if I see from the log that you started at 10:30, there's nothing I can do to help you here. I'm sorry. But if you started, at a reasonable time and something happened with Zoom, then I can work, not Zoom, but Canvas, I can work with that. Okay. All right. Any questions about that at this point? No. Let me stop the share here. Yes, the labs are touted, and I'm going to go to that site right now. Okay. Does the lockdown browser, any questions about the lockdown browser? Everybody understands it? Okay. What I want to do is I want to share the screen now with the student view. This is the view you get of Canvas, which is totally different from my view. Okay, so this is Canvas. Okay. And this is the view you get when you log in, right? It sends you directly to the home, which there you will see on your right-hand side, you have notifications, which tells you what is coming up. So you keep on track with all that. Okay. Now you also will see this grayed out area. These are modules. There's general, if I click on that module, there's general information that we just talked about. There are a couple of tables that you must print. Okay. Because you're going to need them during your exam time. And if you remember, we're doing the lockdown browser. It won't allow you to access them electronically. So print these two tables. One is a periodic table, one is a shapes table. We're going to use those two tables extensively, okay, for a lot of stuff. So get them printed out as soon as you can. And utilize, so we can utilize. Now, there are some other information here for you that it might help you. I've added some videos that deal with Dr. McGuire and her kind of helpful hints and working with chemistry and how to study and so forth. If you take some time to listen to this, the information here, because it could pertain not only for chemistry, but for other topics. Okay. Other topics. So there's a lot of good information there. Okay. On the far left, we have the panel. It's listed. I got home, Zoom meetings. Obviously, you know where it's at because you're here already. Okay. Then you have YouTube recordings. That will send you to my YouTube what do you call it, channel that I upload all this information up to the YouTube channel. And some students have subscribed to the channel. So whenever I upload it, and it takes a few minutes because I got to convert mine. I got to get it converted from the Zoom format to an MP4. And then when I upload it to YouTube, it's got to be converted to YouTube's format. So it takes a little bit of time. And some students have subscribed to that channel. And then when I upload it in YouTube, they get notified and then they can go in there and listen to it. Okay. Announcements. I will send out announcements. I have some announcements in there already, but not only my announcements, but the SEC also uses this to send you guys announcements. So yeah, it's a good area, good source to get information concerning SEC. But I have some of my own that I got one up here, as you can see, talk about significant figures. That's the topic that we're going to get into in detail later on. Okay, we got the syllabus here. If we click on that, the nice thing about this, you have a course summary down at the bottom, which tells you what's coming up and what's due. Okay, there's a good place to find out what's coming up. You can click it and do the assignment. That's one area. I do have the syllabus here that you can download for you yourself, or I believe you can view it directly here on the course on the web. All right, now let's click to the grades. And a quick review, some of you, this might be the first time you use Canvas. If it is, go in there and click all the buttons, look at what everything does. But under grades, it just shows you all the grades of all the assignments and where you're at, okay? And I'm told I've not been able to do that, but maybe some of you out there may know this, that you can type in a number and do a what if scenario. So yeah, I guess so. Just click it. You can do a what if scenario. See, what kind of grade do you get if I type in whatever value you think you can get. Okay, that's my grades. Now we have assignments. I'm going to come back to modules here in a bit. These are all the assignments. They're all online. Okay, online assignments. And then SEC has a little link there for their library. Now, the study mate. I was asked the question what the nomenclature was. Nomenclature, as I stated earlier, has to do with naming compounds, either given the formula, give the name, have the name, give the formula, vice versa. Well, I've added a resource here for you, and I call that, it's called Study Mate. If you click on that, okay, let's continue to study mate. It's going to give you this information here, tutorials, but you can continue to it. There is an assignment that I created for you. It's listed up here called Nomenclature Practice. Okay. If you click on that link, it sends you to this site. Now you have a choice here. You can use either flashing cards or matching. What it's done is I uploaded about 140 some different chemical names and formulas, okay, up to this study mate site. And then it takes that data and you can either use crossword puzzle or pick a letter. Unfortunately, study mate doesn't understand things like hyphens. So the only two choices I think that work best and that confuse you are the flashcard or matching. Okay, so let me click on one. Okay, when I click on one, I have 143 flashcards. What it does is it gives me the name of the compound, dinitrogen monoxide. Okay, with that, given that name, now with a piece of paper, I can write down the formula. And when I check to make sure I wrote it down correctly, I flip the card and it gives me the formula. Now, bear in mind that when we write formulas, we generally have subscripts. And unfortunately, StudyMate does not support subscript. So if this were, the formula is N2O, which, keep in mind, like I just stated, it doesn't support subscript. So in reality, it will be written like this. Okay, so that 2 will be a subscript. Okay, but knowing that, you see that that's the formula. And then I can try another one. Let me clear that up real quick. Okay, try a different one. Here I've got sulfur tetrachloride. Okay, now right now you don't know what all this was all about, but you will learn. You will learn. We got sulfur, you know the symbol S. Tetra, you know that's a prefix for 4. And chloride, we'll know the symbol for that would be Cl. So that would be SCl subscript 4. And there it is. So StudyMate is a tool for you to help you practice the flashcards. Okay, help you practice doing that. If you go matching, you get the same 143, but written differently. Here we have phosphorus trichloride. Okay, so with that, we select the choices. We've got phosphorus, which is P, the symbol P, the prefix tri, which means 3, and chloride. Okay, so we look for the PCl3. You're right. Okay, so there's a tool for you to help you with respect to that nomenclature exam, and that's StudyMate. Okay, now let's go to modules. In the modules, here's the first module. The welcome is something that it gives you information about the course and so forth. We just talked about that. The second module is something from SEC. There's a lot of information in there from SEC that you may want to take a look at. You may need to know about it. You may want to know more stuff about it, more information. There it is right there. Okay, that's SEC information. My information starts off with additional chemistry resources. What I've added for you are 4 simulations that will help you understand some of the concept of chemistry. Okay. For example, if you click on build an atom, it sends you to a site which is run by the University of Colorado and the simulations that helps you put the particles of atoms together. We're going to talk about this. There's only 3 particles that we're going to talk about: protons, neutrons, and electrons. You will see here that when I add 1 proton, I created hydrogen. When I add a second proton, I created helium. But when I add neutrons, I didn't create any new element, still the same element, but I just created what we call an isotope. So anyway, when we get to this topic, this will help you visualize what I'm talking about by you actually grabbing the protons and creating different elements and then playing with the electrons and see how they work and so forth. Okay, so there's additional information for you. Now, let me go back to the modules. Chapter 1. Every chapter, 1 through 16, has a module. You have chapter 1, overview. This is an overview of the topics that we're going to talk about. Okay. Then incorporated in there is a textbook for that particular chapter. Now, some students have taken those, they're all PDF formats. Everything I send you obviously is PDF format. You can download them, print them out if you need hard copies. Some people need hard copy, and that's fine. Okay. So you have that for you. So here's chapter 1. Here's a textbook. You don't have to buy anything. You don't have to buy a textbook. It's there for you. Now, in conjunction with GCC, because a lot of this was created by GCC staff and myself, we were involved with this. Okay. We have videos that, if you click on that, pertain to the particular chapter that I'm going to talk about. And Dr. Kim Smith from GCC has created videos for chapter 1. So now you have an additional version of chapter 1 given by Dr. Kim, and then my version that I'm going to upload eventually to my YouTube. So you have two sources here of the topic of chapter 1. I found that when we say talk about atoms, sometimes it helps if there's a concept you don't quite get. Sometimes it helps to listen to someone else present the information. Maybe they present it slightly different, and that may help you. Well, anyway, here's every chapter so far. Every chapter that we have has 3 videos of that chapter. Okay. Not to be mistaken with the videos that we create from the lecture that we talk. Okay, so you have that. Now you have a worksheet, and that worksheet is, let me click on it. It's practice problems for you. Okay, where you have questions asked about that chapter. And obviously we put the answers there for you, but don't look at the answers. Work the problem. See if you can answer them. Because a lot of these questions are patterned for the questions on the exams. Okay, so and obviously some questions we have to, if you do have to do calculations and so forth, which you will in some of the chapters, we have to write that question a little bit differently than if we were face to face. So, but nevertheless, the questions asked on the exams are patterned after the worksheets. Okay, let's go back. Where was I? All right. Once you're done with all that, I have here, and it's like a little rocket, a little plane there. That is the homework for that chapter, online homework. Okay. I also included my PowerPoint slides in a 1-up PDF format. So all the slides that I utilize, I also given to you here in this particular chapter. So you have their access, you have the PDF format. I can't give you the actual PowerPoints, but I can give you the PDF format. Okay. And then I've included, for at least for chapter 1, because that's due this week, is that activity to check your lockdown browser and make sure it's working, functioning properly for you. Okay, you just have to answer the question and make sure it works okay, and then you're good to go. Yeah, if you have the lockdown browser, you don't have to go through the whole downloading and aspect. You just click on that, answer the questions, you're good to go. All right. And like I stated, every chapter has the same format. You have an overview, you have the textbook, you have videos, you have worksheet, and the homework associated with that chapter, and then the PDF files. Now, in chapter 3, I incorporated, because chapter 3, the first exam is over chapters 1 through 3. You have the link to the first exam. Okay, so you can access everything you need via the modules. Okay, or you can go to assignments and do the same thing as far as assignments are concerned, and that is a breakdown of the assignments and what to do and so forth. So there are a variety of ways for you to make sure that you are accessing the information that you need to do with respect to this course. Now, on the far left, you have the calendar. If we click on that calendar, okay, it will list all the assignments that are due throughout the month coming up. Okay. Now, in your notifications, you can set it up to tell you something's coming up. What other students do, and it works well, is if you look in the far right here, you see where it links, it says calendar feed. Click on that. What that does is a little link that you can highlight, copy and paste it, and then email it to yourself. Open up your email and then download the ICS file. And what that does is it synchronizes your computer calendar with this calendar. So you can, at a glance, see what's coming up, and it'll tell you it'll be on your computer calendar. So there's one format right there. But this lays it all out for you, the calendar. And let's see. I believe I have it. Oh, one last thing. You know what? I am missing this. I'm gonna have to give you this link. What I'm missing is this particular link. I can give you this link right now. Uh-oh. My computer is acting up here. Okay. This particular link, oh, that should have been to everybody. Let's try that again. Okay. This link sends you to the SEC course website. Now, like I stated, I use the same textbooks, similar exams as here, but this is another additional resource for you, loaded with a lot of information for you. For example, if we click on the far left here, where it says OER textbooks and videos, maybe not, something's going crazy here. Let me stop the share for a minute. For some reason, I wonder if my bandwidth is going crazy. Bear with me for a second. Okay, I think whatever happened, stop. Anyway, with that link sends you to this particular website, which is additional resources for you because I utilize, like I stated, the textbook and so forth, same textbook. This textbook was created by the faculty of Maricopa Community College. And because most textbooks out there in chemistry are pretty high dollar. And we're trying to find ways to reduce the cost of this. So the only cost for you would be the printing if you want to print them out. Okay. If you go to the first link in the far upper left, you'll see this table, and you got the chapter, column, worksheet, links, and the first one is the third column from the left is the videos. Earlier, I showed you additional videos. That's what these are. These are those additional videos. That is the same chapter book, chapter 1. That is the same worksheet pertaining to matter. And then in the far right is the same chapter videos by Dr. Kim. However, they have captions. If you need captions, that will help you out right there. Okay. Now, so everything on the modules is here, is where this came from. Let me go back. If you want to know more stuff, just for fun, animations and videos, click on this one here called animation and videos for fun. There's a lot of stuff in there that gives you environmental videos, teaching chemistry, all kinds of pretty cool stuff. Okay, even some cool chemical videos that we tell you don't try this at home, but you know, you, who knows? Like you can try the Diet Coke and the Mentos, but I would try it outside. You might make a mess inside. So a lot of stuff here for you. There are some old homework examples with the key on the far right. They're PDF files. Feel free to click on those and look at them. Again, the problems, though different from what you see in your exam, will be very similar. Okay, so more resources. We also have old exams here. Obviously, 2016 old exams, but keep in mind, even though they're old, they're very similar to what some of the questions we ask. They just, you know, the numbers have been changed to protect the innocent, as they say. Okay. And so I believe that's basically all I have with respect to information concerning Canvas, intro, and so forth. So any questions pertaining to this about the assignments? You see what needs to be done, right? All right, what I got to do is stretch my legs here a little bit. Let's take about 15 minutes, okay? It'll take 10 minutes. We'll come back at say 2:35. Clock says 2:20. Yeah, let's come back at 2:35. And then I will continue. I will start with chapter 1, right? Just give you some time to look at that link and look at the information there about the course website. All right, let me pause this. Okay, guys, I'm back. Just one last aspect about the website. Let me go back and share it. Again, using your view. But if you notice, when you're at the syllabus tab, on the far right has a little calendar. The highlighted, the ones in obviously darker color, represent that something is due. So you can, at a glance, you can see that starting not only this week, but next week, you're going to have a lot of stuff due. Okay. So the point is this. Well, question number 1. Does everybody understand where they need to get their assignments? Is there any question about where it's at? I think it's laid out pretty good. Because if you go to the modules on the far left, it's all laid out per chapter. So within the chapter, you know, you can go in there and get the information you need to get with respect to textbook, with respect to overview, respect to more videos, with respect to worksheets for that chapter, and with respect to the PowerPoint slides that I utilize, okay? And the assignments that are due, that are related to that particular chapter. Okay. I asked this because in the past, I've had questions like 2 or 3 weeks before the semester. I can't find my text. So I want to make sure everybody knows where they get the information. And then I sent you a link to an additional website that you can get more information. Okay, so there's a lot of resources for you to help you out. Okay. Any questions before we continue? Any questions, comments, concerns? No? Okay, well, in that case, you know what? Let's buckle our seatbelts and let's jump right in. Oh, one last thing. I want to verify this. These are the people that I do not have no attendance. I have no attendance. Victoria, are you here? Alisa, are you here? I don't see the name up there, so okay. All right. Well, let us start off with good old chapter 1. Okay. Good old chapter.
Excuse me.
Yes, go right ahead.
Hi, I'm sorry, but Victoria typed in here that she's here and that she's just having audio issues, but she put
Oh,
in the chat. I don't know if you can see it. I just want to say that.
Yeah,
for
she
her.
put it in at the beginning of class. She's been here.
oh, okay. Got you. Got you. Okay. Got you. Good thing. Good thing I asked myself that question. Thank you. Okay, Victoria's here. How about Elisa? Did I miss you? Audio issues? No problem. I got it. So Elisa Guerin, Geren. Okay. Thank you for pointing that out. Yeah. Okay. Well, let us proceed. Okay. Any other questions, issues? We all know where we're at with respect to Canvas. I can't overemphasize that. I don't want to be told, I didn't know, I don't know where to get this or get that. I'm hoping I was thorough. But occasionally, sometimes I miss things. All right, let's talk about matter. Now, first of all, let me talk about a property of matter. And I use this slide here. All right, let's for a moment have the ability to be able to identify and mark one carbon atom. It's a pretty good thing to do if you're able to do that. But let's assume right now for a moment that we can. And so we got this one carbon atom that is built into the structure of the grass. It could be in any form of in the structure of the grass. It could be in the form of some kind of grass tissue or something. Okay. Well, my apologies to vegetarians. My partner is a vegetarian. She's like, don't use this example, but I think it really drives it. I'm a semi-vegetarian, so pescatarian, I believe they call it. Well, how's the grass? Okay. And that carbon that we locked into and we marked that was in the grass molecule now is transferred into the cow. It's in a different format. It could be in any type of format, but it's incorporated into the body of that cow. Okay. Well, I'm assuming here you know where this is going. Okay. So here we have that hamburger. That carbon now has been transferred and put into a hamburger, and that carbon then is ingested by us. It's still carbon. It has 6 protons. We're going to talk about this in a bit. Carbon has 6 protons. That's what identifies that carbon atom. It had 6 protons when it was in the grass format, had 6 protons when it was in the cow format, and now it gets ingested by the human and it's incorporated into the human body in some format, but it still has 6 protons. Okay, 6 protons. Well, in our process of metabolism, that carbon can get converted to, let's say, carbon dioxide in us. And when it gets converted, we exhale carbon dioxide. And so that carbon that began in the grass has 6 protons, goes to the atoms, still has 6 protons, but a different format, goes into the human, still has 6 protons, but it's in a different format of the human, gets metabolized in some manner, and again goes out into the atmosphere. And guess what happens? Now that carbon in the format of carbon dioxide is reabsorbed by, again, this may be grass molecule, some other plant life, because carbon dioxide obviously is a good thing for plant life. And then it gets reincorporated into its structure. So that carbon, the full cycle is still carbon. Okay. still has 6 protons in the form of grass, in the form of the cow, in the form of the human, in the form of carbon dioxide. Still has 6 carbons. It's in a different format, as different structure, okay, but it's still carbon. And that is what we call the conservation of matter, okay? We're neither destroying it nor we are creating it. We're just moving things around, putting it into a different structure. This is a key aspect that we're going to do when we get into what we call balancing chemical reactions, okay? But we will talk a lot about more, but keep this in mind with respect to the conservation of matter, and that's what we talk about. So what exactly is chemistry? Well, chemistry is defined here is the study of the composition, what things are made up of, the structure, how things are put together, what these molecules, how they're put together, how's their structure, the properties, be it a physical property or be it a chemical property. What we mean by a physical property, water, for example, will boil at 100 degrees Celsius and it will freeze at 0 degrees Celsius. That is a physical property of water. And chemical changes it can undergo. Well, we know that we can take water, for example, and hit it with some electricity, and we break that water down into these elements and break it down into hydrogen and oxygen. That is a chemical process. Now, the key difference between a physical process and a chemical process is this. When we do a physical process or a physical change, we do not change the structure. H2O, which we all know is water, is the same H2O, whether it's a solid as in ice, or it's a liquid as in liquid water, or if it's a gas and vapor, it's still H2O. We haven't done anything to change that structure. That is a physical change. A chemical change by totally different. We can take water and break it down so we can create again hydrogen and oxygen, because we know that water is made up of hydrogen and oxygen combined together. Okay, but when we do a chemical change, we can't bring it back to where the way it was to begin with structurally. Okay, when we do a physical change, yes, we've done nothing to the structure. It still has the same structure. All right, so our model so far, at least at the current time, and it could change tomorrow. All right, seriously, because we will learn that our models have changed over time of how atoms are put together. And the more information we get, the more obviously, we got to change our model. But at the current time, all matter is made up of atoms. Okay. Now, we're going to learn about the atoms. We're going to talk about the atoms, and we're going to learn that these atoms are made up of subatomic particles, what we call subatomic. They're below, here's the atom, and then this atom is made up of smaller components. And we're going to talk about specifically 3 components or subatomic particles. That is the proton, the neutron, and the electron. Okay. Those 3 components make up what we call the atomic mass. That is the weight, the mass. Now, the term about mass and weight, that term is kind of used interchangeably. Technically, we're talking about mass because weight is governed by the gravitational forces. Weight here on the Earth is different than weight on the moon, okay? But the mass is the same here on Earth, whether it's here on Earth or on the moon, but our weight's different because of the gravitational forces. So weight is governed by the gravitational forces, and mass is governed by the amount of matter a material is made up of. Okay, but since we're stuck on the Earth, we tend to interchange the term weight and mass, but just be aware that they're 2 different things, okay? So, atoms composed of protons, neutrons, electrons. And guess what? Those guys are made up of even smaller particles, but we're not going to talk about those for Chem 130. And so it's pretty amazing that eventually the theory is that everything is made up of one type of particle and how they're put together. You know, how they're put together makes a big difference. Big difference. For example, does anybody know what, a pure diamond is made up of? Carbon, exactly. Good old fashioned carbon. And then anybody ever heard of it's a dry lubricant? I'm having a senior moment. Um, well, some old leads, pencil leads have carbon in it. Okay. Uh, and there are some dry lubricants that are made up of carbon material. And we're like, whoa, wait a minute, wait a minute. The diamond, for example, is the hardest material on earth that we know of. Hardest material on earth, and it's made up of nothing but carbon. And yet we have a dry lubricant or like old fashioned pencil lead that's made up of carbon. And we're like, whoa, wait a minute, that's not very hard. But they're both made of carbon, just like I said earlier, 6 protons in both cases. So why is it that the diamond's so hard and the carbon lubricant is not? And it is because the way the carbon atoms are put together relative to each other. And in a diamond, they're put together structurally in a certain function, in a certain manner, compared to the dry graphite powder. Thank you very much. I couldn't remember. I was having a senior moment. I'm getting more of those. Anyway, graphite powder, and it's still carbon. But the way the structure is, how the atoms are bonded to each other, you find the properties, how diamonds tough, hard as the toughest thing there is. And then we got graphite powder, which is made up of nothing but carbon. It's a dry lubricant, not hard at all. So it's amazing how the structure plays a big factor and how the atoms are put together. Another good example, you may not be familiar, but we're all familiar with styrofoam cups. Styrofoam cups are very, very easy to break. You take a styrofoam cup, crush it in your hand, no problem. And it's styrofoam is made up of nothing but carbon, hydrogen, maybe a little bit, mostly carbon, hydrogen. That's it. Okay. But I can play with the structure of polystyrene, make it even more dense, and make material that I can build buildings with, that I can build bridges with. Made up of nothing but carbon and hydrogen. And the polystyrene cups we're more familiar with are not very strong. And it's the difference is how the structures are all put together relative to each other. And it's all related to, guess what? These crazy electrons. We have a lot to say about these electrons. Same electrons, you get up in the morning, you got a bad hair day, your hair goes poof. Okay? Those static, your hair's going crazy. Crazy electrons. We'll talk about that. Okay? We're going to learn about chemical bonding. Okay? Now, you would think with all the millions of chemicals out there in the world that we'll have all kinds of chemical bonding, and I'm here to tell you, there's only 2 types of chemical bonding. One we call ionic bonding and one we call covalent bonding, and that's it. And we're going to have a whole chapter about that. Okay? Chemical reactions. Again, you would think it'd be like 10,000 billion different types of chemical reactions, and there's not. There's only 6 types of chemical reactions that we're aware of. Okay. One of which you may be familiar with. You ever had a bad day with antacid, heartburn, and so forth. What do? You take some Tums, right? Take a little Tums, or you take some little milk of magnesia. Well, guess what? In your stomach, you have hydrochloric acid. Okay. You eat a base, which is Tums, calcium hydroxide maybe, or magnesium hydroxide. It neutralizes that acid. That's a chemical reaction occurring in your stomach. Okay. If you drove your vehicle today, someplace to go to point A to point B, you did a chemical reaction in that vehicle. You did a combustion reaction. That's 2 types of the 6 that we're going to talk about. Okay. We're going to talk about the periodic table and periodic trends. Well, What do I mean about that? Well, the periodic table that we're going to talk about, oh, where'd it go? Is that one. Okay. Now I've added some stuff here. You may not have it on the periodic table you have, but you can add it later on when we talk about it. So ignore the stuff in the circles for right now. All right. And the thing in blue, but we will eventually talk all about this. All right. There's 118 elements right now that we know of. The last couple, 2 or 3 were created, let's say a couple years ago, and it filled up this periodic table. Okay. And we're going to talk at length about this periodic table. No, we're not going to memorize all 118 of them, but we're going to be familiar with at least the first 20, maybe 30 elements in here. Okay. But we're going to learn some certain trends in the periodic table. Included in the periodic table, look at the other tables at the bottom. One table in the bottom left called polyatomic ions. We're going to talk about those, learn about those. Down at the bottom right, we have something called solubility rules. That means what the solubility of certain compounds in water, either are going to be insoluble or soluble. We're going to learn about those. And then we have what's called the activity series. We're going to learn about those too. So this periodic table we're going to use extensively. Okay, make reference to it all the time. The other one is called the shapes table. Again, we're going to use this to actually determine the structure of compounds for the bottom table here, the geometry of compounds. Because remember, we live in a 3-dimensional world. And sometimes when we write structures, we're in 2 dimensions, but in reality, we're 3 dimensions. So this table down here helps us understand what's happening in a 3-dimensional format. And then on top, you see a lot of more information that we will get to eventually you can utilize. Okay. All right, so let's go back. So we're going to learn about periodic table. We've got a whole chapter on it. We're going to learn about acids, which I just mentioned one acid, okay? The one in your stomach called hydrochloric acid. It has the formula H, hydrogen, capital H, and Cl for chloride, okay? We're going to learn about bases. I mentioned one earlier, magnesium hydroxide. That's formed in milk of magnesium, or calcium hydroxide. Find that in Tums. Any hydroxide is a base. Okay. We're going to talk about those. Electrolytes, you're familiar, maybe you are or not, but you know, these bottles of water you can buy, you get like Pedialyte, for example. You have children, kid's sick, he's got a fever. What do they recommend you feed him? Pedialyte. And the reason you feed them Pedialyte is because they have electrolytes. They have these ions that you need in your body. Some important ions that you need are like sodium and potassium. Those are things that are a lot more of different types, but this, for example, those are things that are needed in the body to function properly, to transfer electrical signals from point A to point B. Okay. And we're going to talk about good old mole. No, not the mole. It's called moles. Okay. Moles is a unit, and sometimes it confuses people. But if I said to you a dozen, what number do you think of? Oh, right. It's a number. The unit dozen is a number. Well, the mole is nothing more than a number. It just happens to be a big, 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 big number. Okay. And then you got this next one, and we'll talk a whole chapter about that. Then this big old fancy word there called stoichiometry. Well, all that means is this: when we talk about chemical reactions, we're going to learn that if we're reacting A plus B, okay, when we have a reaction of A plus B, and let me do this, give a general reaction. Okay, so if we have A plus B reacts to give us C, we may have these numbers in front we call coefficients, where in this case says I need 2 A's and 1 B to give me maybe 4 A's. Okay. These numbers up front of the chemical A, B, and C, the chemical structure, are coefficients. And that relationship 2 to 1, 2 to 4 is the stoichiometry. You're familiar with this. Okay. I got a car. How many tires do I need to put on that car? 4 tires. What is that ratio? 4 to 1. That's the stoichiometry of a car and tires. 4 tires to 1 car. I got a bicycle, two wheel, 1 frame to 2 tires. I got a unicycle, 1 frame to 1 tire, right? That is the stoichiometry. So they put all this fancy word to tell you something that you're already familiar with, okay? And make it kind of confuse you. That's all they're doing. All right. Then we talk about intermolecular forces, and that is related to the diamond that we just talked about. These intermolecular forces, this is how molecules interact with each other. Don't form a chemical bond, but how they interact with each other. You know, it's akin to forces like 2 magnets coming together. I got 2 magnets here. You know, they're attracted to each other. You know, they're not quite bonded, but they're attracted to each other. These forces can affect the properties of compounds. We know that honey, for example, is very thick. It takes, it flows slowly compared to water. And that's because the intermolecular forces, the molecules of honey, are interacting with each other more strongly than they are with water. Now, how can we make honey flow a little faster? What do? We heat it up. If we heat it up, we break up those intermolecular forces and it flows much more readily compared to, say, room temperature. Okay. All right. So then we're going to talk about solutions, and then finally we're going to talk about gases. Okay. Very short chapter. By the way, chapter 16 is the last chapter, obviously, and you won't find any of the exams will not have chapter 16 nor the final, but there will be a homework. And the reason I do that is normally that's the last chapter of the semester, and we kind of jump on it very quickly, so you won't find it. You won't find it on the last exam number 5, nor will you find any questions about it in the final exam, but you will find it with respect to homework. Okay, so branches of chemistry, like any field, those of you in nursing field, you have different types of nurses, working in different fields, psychiatry, ER, geriatric, like old guys, things like that. Well, we're no different than chemists. Okay, chemists same way. We got our own different little area that we focus on. My particular area that I have my training is it is called organic chemistry. As I explained earlier in my introduction, that I used to be in construction, and so I like building things, putting things together. And so when I got into chemistry, to me, that was no different than construction of organic molecules, because you look at a molecule that you want to build, and you try to figure out ways to put it together. And so I kind of fell into that. But we have people who work with inorganic chemistry. Normally, those are chemists that deal with compounds that are classified as inorganic. Organic most of the time will contain most carbon, hydrogen, nitrogen, oxygen. Inorganic, we're dealing with metals in there. Then we got biochemistry. These are the guys that deal with biological chemical processes. Chemical education. Dr. Kim Smith, who did the videos I spoke about earlier, her doctorate's in chemical education. Then we got the environmental chemists, they got the forensic chemistry. I think there's 1 or 2 forensic majors involved there. Point is that everything, all of these different fields, all related to chemistry. There's chemistry all around us. It really, everything that I can think of, that if you really stop and think about it, involves the use of chemistry. Okay, obviously batteries, the fact that if you're sitting there working off your electronic device of batteries, there's a chemical reaction occurring there to generate, guess what? Electrons. Is my favorite little subatomic particles. These electrons are the ones that are powering your electronic device through a chemical reaction. Okay. Same electrons that, same type of structure of electrons to give you that bad hair day, that frizz and stuff. Give you the walk on carpet, touch something, what happens? Zap. You call it static charge, electrons. Okay. Electricity, making clean water, energy. I mean, the list goes on. TNT, for example, is good old fashioned dynamite. That's a big chemical reaction. Okay. Fire is a chemical reaction. In fact, it's a combustion reaction. Okay. The shampoo, the makeup you utilize, based on the chemical properties and with respect to what we add to shampoo, which is pretty hefty. If you were to look at the label of all the chemicals used in the typical shampoo, all this formulation is utilized in certain ratios to make sure you get your hair shiny and clean and so forth. And makeup is another one that you want makeup that will, withstand the environment, right? You don't want makeup that first time you hit water washes off. So I'm going to use that as an example quite often when we talk about polarity, whether something was dissolved in water or not. So the list goes on, the list there. Everything that you can think of, even as you sit there listening to me, you're sitting there, there's chemical reactions occurring in your body throughout just in your stomach, and just list goes on. Okay. So it's pretty involved. Now there's roughly, as scientists, we utilize the scientific method. Right now I only show 4 steps. Really there's what, 6 steps. And what's involved? Well, in the first step in the scientific method, which by the way, you may even use this and not know that's how you do it, but it's just simply called the scientific method. Okay, you make an observation. Something happens. Okay. For example, you put soda bottle in a freezer, and guess what? It exploded. Okay. So you look at it and think, well, why did it explode? Why? Why is it? So you make a hypothesis. Well, what's in my soda? Most of it's water. Most of the material is water. So you might make a hypothesis. It's a guess, your best guess, and say, maybe when water freezes, it expands. Because that would only explain why the soda burst in the freezer. That's a good hypothesis. So you make that hypothesis. So you go and you research the literature and find out, does anybody else looked at this before? I don't want to start doing experiments unless someone's already done it. So why am I going to do experiments if it's already been reported? So you look up the resources, okay? And you find some, but not a lot. So you start thinking, all right, well, let me create some experiments, okay? So you might do things like, I don't know, put more soda in the water in the freezer, measure the volume that you utilize, try different material of, solutions of water, try different things, okay? So you perform experiments. You look at your results of your experiments, you analyze your hypothesis of what you thought may be happening, and then if necessary, you might repeat some experiments. If you need to, you say, oh, this one's not very conclusive, let me try it again. All right, so you repeat some experiments, maybe not, okay? But based on what you find with respect to your experiments, you draw a conclusion. And your conclusion is, yes, my hypothesis is correct, that when I put water and it freezes, it expands, hence my soda pop exploded, okay? And then hopefully you publish it, and then other scientists will look at it and they will repeat your experiments, and then hopefully they get the same results. And if it is, eventually everybody's getting the same results, I think everyone can agree, the scientific community, and say, yeah, water expands when it freezes based on all the research that we've done about it, okay? Occasionally it doesn't work that way. There are times that you report something and then someone else tries it and it doesn't work. Back in the 80s, there was a big old battle. I call it the East Coast, West Coast battle, having to do with some type of energy that was being created. Anyway, it was finally disproven, but there was a big battle. the big Ivy League schools were lined up. The East Coast were saying, "No, you guys are a bunch of crazies out there in California. Nothing's happening." And anyway, when I was in graduate school at the time, we did some experiments. We couldn't get the same results. It would have been cool because it would have created a lot of energy, but it was a fluke. Anyway, thing about scientific method and being a scientist, we got to make good observations. Okay, in the lab, watch the videos carefully. Okay, because you'll be asked questions about what you observe. Okay, and be very specific with respect to your observations. Okay, so things like color. No color is colorless, not clear, because clear can be a clear separate entity in itself. If something is clear, there's no material floating around in the solution. Okay, looking at the state of the matter. Is it a liquid? Is it a solid? Is it a gas? Those are the three states of matter that we're going to be looking at: solid, liquid, and gas. There is a fourth one, but we're not going to talk about that, plasma. We're just dealing with solid, liquid, and gas. Okay. What we do know is this: that matter is anything that has mass, and that all matter is composed of atoms. Okay, of atoms. Now, the three states of matter and how we depict them in diagrams. Okay, we have solid, liquid, and gas. And if you look at the diagram below, and the far left, you can see the little spheres represent some material, some chunk of matter. Okay, it's an atom of something, or it could be a molecule. But notice how ordered they are in the solid phase. Everything's nice and structured, so that would designate a solid state. Right here. Notice how everybody, where's my arrow? Notice how all the arrows are nice and the spheres are nice and organized and so forth. Now, in the liquid state, they're a little bit ordered, but there's some disorder there. They're kind of loose. They're moving around a little bit. In the solid state, the atoms don't move. They're stuck together in that position. It's a solid. Okay. The liquid, they're not as ordered as the solid, but you can see how they can move around. And the gas phase, these guys are total in disarray. Okay. They're all separated. So you can see that in the solid phase, the IMF, remember I talked earlier about intermolecular forces? Those are the forces involved that other molecules interact with each other. Those are the ones that are, here, they're very strong. They're attached to each other. Over here in the liquid phase, they're a little bit looser, if you will. Not because they're moving around. They're not as strong. And then in the gas phase, they're essentially non-existent because these guys are like totally separated from each other. They're not interacting with each other very much. Okay. And that has a big effect on the chemical properties, the physical properties of these chemicals. So anyway, be familiar with how these diagrams depict a solid, a liquid, and a gas, because you could be given a one of these diagrams with no listing and say, okay, which one here, A, B, or C, represents a liquid, things like that. Okay. All right. Now, a property of a solid. Solids have a fixed shape and a fixed volume. Obviously, this pin here has a shape and it has a volume that we can actually either measure directly or indirectly by maybe placing it in the liquid and measuring the amount of liquid it displaces, and that gives us the volume of this chunk of metal. Sometimes we're lucky, we get something like a rectangle that we can actually measure length, width, and height to give us the volume. But it has fixed shape, fixed volume. The atoms are, as shown in the diagram, in the solid form. They're all hooked up and they're reacting with each other. They vibrate. They're still moving, but they're vibrating in place. Okay. And solids generally could be crystalline or non-crystalline, crystal form. We can't compress them anymore. They're pretty much already in a high compressed form. Excuse my little one back here, she's screaming. Particles are very close together. Okay, so we can't compress them very much. You know, if you look at that diagram, you can see here that I can't put pressure in that solid anymore. I can put pressure, but what's going to happen more than likely is it's going to crack and break. So those molecules cannot come together any closer than they are already. The same is true for a liquid. I may get a little bit of compressibility, but not much, because those molecules are pretty close to each other, which is a good thing in liquids, because that's why we have hydraulics. And with hydraulics, you have things like power steering, power brakes. I don't know if you ever driven a vehicle with no power steering. It's a little challenging. It can be. And if power brakes, no power brakes, you really got to press hard on the brakes. All right. So the fixed shape atoms. Where am I? Okay, most solids have a higher density than the liquid state. Now, what do I mean by density? As we'll get used to this, density is a ratio, okay? It is a ratio defined here in the bottom right as mass over volume. All matter has density, okay? You have density. If you can get your mass, which is your weight, and if we get your volume, that is the volume that you have in your body, you have a particular density, which is specific for you, okay? But the point is that this value is simply a ratio. And being a ratio, it has units. Okay. And so we have density is equal to, normally the units are grams per volume, which is the units for volume are milliliters. Okay, we all know about liters, but we're going to have milliliters, and we're going to be using the majority of the time, all the time, when we do calculations, we're going to be using metric units. Okay, and we're going to have a whole chapter about, not chapter, a whole section about metric units. Yes, we're going to use English units, but only to be able to convert from metric to English. But the calculations further down the road after that will always be in metric. But that is a ratio, okay? And here's the thing about all the ratios that we're going to talk about. It is no different than the ratio of miles per hour, okay? Miles per hour. Or dollars per hour. You know that ratio, right? If you're working, you know that's an important ratio. That's how much money you're making per hour if you're an hourly state. Or if you're not, you're paid by the yearly, it's still dollars per year, okay? If you're paid not on the hourly state. But that ratio is very important, because we can use that and write that one or two ways. Either, for example, grams per milliliter written like that, or we can write it with the units milliliters per gram. Okay, and knowing that, we can keep track of our units to do calculations. Okay, by keeping track of your units and setting up problems correctly based on their units, it would help you drastically when we do this calculation. We'll have more examples on that. Okay. Ice is, it floats. Why does it float? Because when water freezes, guess what? It does expand. And so the volume gets bigger for the same amount of mass. So that ratio of mass over volume gets smaller, becomes less than the original density. And so it's less than 1, for example, and therefore being less than 1, it will float in water, because the water has a density of 1 gram per milliliter. And anything less than 1 floats. Anything more than 1 sinks to the ground. Okay, solids, because they're locked in place, they don't move. They don't diffuse. They're locked, so they won't come out. Back in my days of working in industry, had a big argument with EPA. I understand what they were dealing with because in my professional career, I worked with a lot of copper metal, which is ironic coming from a hometown that mines copper. So I ended up working with copper metal. Figure that one out, right? So anyway, because we worked with copper metal and because we changed it, either we etched it chemically or we changed it mechanically with what are called CNC machines, we cut into the metal. We were governed by the EPA rules and regulations, which required us to report how much copper metal we use on a yearly basis. And I talked to the chemist, scientists / I don't know what they were from the EPA, and they told me that because of solid metal, that we run the risk of a solid atom going into the environment. And I'm like, are you serious? Okay. I took that back to talk to a couple of chemists from my old graduate school, and we had a good laugh. But anyway, it's highly unlikely, not a 0% probability, but it's very, 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 very low that a solid particle atom will shoot off and go into the environment unless you heat it. Now you heat it very high temperature, and that's a different ballgame. We didn't heat it that high temperature. We're talking 1,000 degrees Celsius. We didn't go that temperature. But anyway, we had to. I lost, so I had to report how much copper we used, even though practically 0 atoms of copper metal went into the environment. All right, some properties of liquids. Liquids take the shape of the container, but have a constant volume. Excuse me. A gallon of milk you put in a gallon container has that shape. I take that same gallon, I put in the 55-gallon drum, has a different shape now, but I still have a gallon, right? Okay, that's how that works with respect to liquids. Different liquids flow at different rates. Okay, makes sense. And again, back to what we call the IMF. We're going to whole chapter later down the road of IMF, intermolecular forces, which are related to these electrons around the molecules. And so, liquids have different rates, diffusion rates or flow rates because of the viscosity, and that is because they have different intermolecular forces. So thick, viscous liquids like oil flow differently than, say, water. Okay, different flows. Liquids are not compressible. They don't compress anymore. And when they have a little bit, but very, very little, because the atoms are pretty close to each other already. Okay. And they have much higher densities than gases. They have a higher ratio of mass over volume. Now, soluble liquids will mix uniformly. Here we go with like dissolves like. Put this in long-term memory. Okay. Like dissolves like. Things that have similar physical properties will dissolve in similar type of solvents. Another way of saying this is water, molecules that have water-like properties. But right now, we're just going to say it this way. Compounds that have water-like properties will dissolve more in water. Case in point, look at Italian dressing. Okay. Those Italian dressing lovers out there, you take that bottle and you let it sit there. You're going to have 2 layers, right? You're going to have your water layer and your oil layer. Oil and water, we know, do not mix, okay? Because they have different properties, okay? But if they are soluble, they will mix uniformly if they're in the liquid phase, okay? What about gases? Well, gases have no shape. They take the shape of their container. Okay. And because they're so far apart from each other, the molecules, that is, they can compress and expand. Okay. The volume increases as atoms get further apart. That makes sense, right? As the atoms get further apart, they increase. You might think, well, wait a minute. How does that? Well, get a balloon, blow it up. Okay. You don't have to blow it up all the way, just blow it up enough to stretch out the balloon. Now get your hot air balloon, your hot air dryer. Don't put it in extreme high, just maybe medium high, and start heating up that balloon. Okay. You're going to notice that balloon expand and get bigger. Okay. Then take that same balloon, stick it in the freezer, and it sit there about an hour. Guess what? That balloon's going to contract. Okay. And it's all related to energy, because as you heat it up, the balloon, those molecules in the balloon absorb that energy and they start to pull away from each other and expands. And then as you stuck that balloon into the freezer, guess what? They contracted because you started to take away that extra energy they have, and they're coming closer together. So the whole volume decreases. Okay. Same thing is true. Another way to do this is in the morning when you go take off, you're going to go on a trip, you're going to drive for about an hour on the highway. Check the tire pressure. Let's say you're at 32 and now drive to wherever you're going to drive on the highway for an hour. And then when you're done, check the pressure again. Guess what? Your pressure is going to be up. Did you add more air to it? No. All you did is because of the travel, you created friction. And that's why you're able to move forward. Without that friction, you're going to be not moving. But you created friction, and that the tires created friction, and tires absorb that energy. That energy is absorbed by the molecules, the air molecules in the tire. They get hot, they repel each other, pressure goes up. Okay. All right. They tend to have low densities, much less than one. When we talk about density, use water as our reference point. Water has a density of 1 gram per milliliter. That's our reference point. And like I stated, anything less than 1 will float on water, and anything greater than 1 will drop like a rock. Okay. So these guys are very, very low density gases. Now, gases, when they're put together and they're mixed, they will mix completely with other gases. And so our atmosphere is made up of a lot of different gases: nitrogen, oxygen, carbon dioxide, noble gases, and God knows what else, a bunch of stuff. And then so they mix quite readily. Okay. Gases exert pressure, and that's simply because they're hitting the sides of the container, which causes a pressure. Now, that being said, we have here solids have a fixed shape. Yes, they do. Do liquids have a fixed shape? Oh, sorry, they also have a fixed volume. I'm going the wrong direction. So solids have fixed shape, fixed volume. Liquids do not have a fixed shape. They're determined, the shape is determined by the container. Okay. But they do have a fixed volume. And gases do not have a fixed shape and do not have a fixed volume. We will learn that only under certain conditions, specifically 0 degrees Celsius and in 1 atmosphere, do gases have a fixed volume. And that volume is 22.4 liters. But we'll learn that right now as it stands, at 1:30, gases do not have a fixed volume. Okay. But we're going to learn that they technically do at under certain conditions. Now, with respect to physical and chemical changes, all right? Now, physical properties, I should say properties, not changes, describes the appearance, for example, of the chemical and some facts about the chemical. For example, the color. Okay, whether a chemical is solid, is blue, yellow, colorless, whatever, that's a physical property. whether it has an odor. There's some solids that have chemicals have a nice odor. And taste, they may taste sweet, they may taste sour, they may taste real nasty. Who knows? They're all different. The texture of the solid, the melting point, and in their physical state. These are the symbols for the physical state: lowercase s, lowercase l, lowercase g for solid, liquid, and gas. Okay. The density, solubility, conductivity, whether it conducts electricity or not, and hardness, how hard a material is. That's a physical property of a chemical, if it's a solid. Okay. With respect to chemical properties, okay, that describes how a substance reacts or behaves. Is it explosive? We all know dynamite is very explosive. Is it corrosive? Your stomach acid, HCl, hydrochloric acid, it's very corrosive. Okay, very corrosive. Is it toxic? Is it a poisonous material? Or maybe it doesn't react, doesn't do anything. It's what we call inert. It just sits there. Okay. Or maybe it does react. There are certain metals that are very, very reactive, for example, in the presence of water. They react violently. Okay. Does it rust, oxidize, or does it break down? These are chemical properties. Now, the difference with respect to physical properties and chemical properties, okay, here's the thing to remember to take away from this part, is when we deal with physical properties and we're changing, let's say, the physical state, it still is the same structure, okay? We don't do anything when we do any physical change. We don't change the structure of the molecule. The chemical properties actually causes a change in the chemical property. Okay, so when we make something that's explosive and it will explode on you, we have totally created a whole new set of chemicals, and spontaneously or whatever happened there. In other words, to bring them back to where they were originally, we have to do something else to bring it back. But once they're out, they're out. And, okay, with physical changes, it's still the same. Nothing's been done to the chemical. Okay. Let me check something here real quick. All right, I have about 1 minute left. I'm gonna stop it here. Page slide 15. Okay. Let me stop. I will continue for this chapter, and we definitely will knock that out on Thursday and jump into chapter 2. Are there any questions? Jump on, get on the course website, take a look, get yourself familiar where everything's at. Don't forget you have a lab due tomorrow. So give yourself plenty of time so you can submit it on the due date. Yes, it will be submitted. You can submit it after the due date, but remember there is a penalty, 5% per day until you reach the 50% mark. See what else? Work ahead. Everything's open with the exception of the exams. Everything's open. Feel free to work ahead if you feel comfortable with that. Feel free to jump and do at least your first attempt of the homeworks. And then once we complete that chapter, then the due date will pop up. I'll give you at least 1 or 2 days after we complete the chapter for that particular chapter to be due. Okay. So any questions